Kiruna, northern Sweden. 200 kilometers north of the polar circle lies the S-Range launch range. This is where Maxus 4 was launched on the 29th of April 2001. Maxus is the largest sounding rocket ever having taken off from European soil, and it enables scientists to conduct experiments under conditions of weightlessness. Why was it launched here, way up in the north of the world? The main reason we launch here in northern Sweden is that we can bring rockets down on land. This means that we can recover the payload and overhaul all the scientific equipment for reuse, which is much cheaper than building new apparatus each time. The other key reason is that for most experiments, the scientists need to get their samples back for evaluation. The data gathered during the flights are not the whole picture. They're often metallic or biological samples, which need to be analyzed in detail after the flight. The rockets are launched either in the second half of November or in April, which is winter time. Why is the timing so important? The reason we launch in what is practically winter, that's to say early spring or late autumn, is that the lakes and rivers are all frozen, and we don't need to worry about the payload falling into one of the many lakes here in the region. The payload is not watertight. That would cost more money and means sending up additional mass, leaving us with less for our experiments. 7 experiments were conducted on this flight, including 2 experiments performed in mirror furnaces. One of these experiments investigated how the quality of a silicon crystal grown in a mirror furnace could be improved by applying a rotating electromagnetic field. With both of the procedures used here, we expect to see improved homogeneity in the distribution of the crystals. Another important point is that we want to compare the results of the experiments to see the difference between the 2 procedures, because we don't know this yet and we're looking forward to the results with great anticipation. The wait before liftoff, an air of tense silence prevails. A few scientists are still carrying out last-minute procedures, then everything will be ready. Maxus 4 lifts off.
-5, 4, 3, 2, 1, 0, 1.
Traveling at a speed of 4,000 meters per second, it will reach a height of 700 kilometers in free flight before returning to Earth on a parabolic path. The payload is detached from the rocket's body and will land with the help of a parachute. The scientists have 12.5 minutes to carry out their experiments, which are either conducted by remote control or are programmed to run automatically and are simply monitored. In this experiment, they're investigating the stability of aqueous foams. It should give them a better understanding of how to stabilize foams on Earth, or likewise, how to avoid foams appearing on top of aqueous solutions. The 12 minutes are soon over and some of the scientists are relieved, but what has happened to the rocket? Has it landed safely? And what about the experiments? The radar data recorded above the location where the rocket should have landed are being scrutinized. A search team leaves to look for the samples on the rocket. The experiment itself went perfectly and according to plan. There were no technical problems. Now we just need to make sure that we get our samples back. Then we need to take a look at the data, because all I know at the moment is that I was able to record all the data as planned. I still need to look at the computer to see what the quality is like, but things look good so far. 1.5 hours later, the rocket is found in Norway. The recovery system failed and the payload crashed down to Earth at 300 kilometers an hour, resulting in total destruction. Unfortunately, the likelihood of the sample surviving an impact of this kind is not high. I can't say more until I see it, but without the samples, the experiment will be a failure, at least in principle, as far as analyzing the material is concerned. But even from this shattered wreckage, something useful could be salvaged. It turns out that all the samples could be recovered completely, even the samples from the silicon experiments, which were critical. There were 10 of these samples, all of which were recovered completely intact. And what was even more amazing, 2 mirror furnace experiments in which crystals had been grown. One sample was in a quartz glass container, the other was hanging freely, and both samples are completely intact. The experiments themselves were insured, so this money can be used to build new experiments. Preparations are already underway for more flights with sounding rockets. And in March 2002, the next rocket will lead Kiruna on a journey into